The 2-watt meter method in a balance system enables us to determine the PF. So let's consider a balanced Y load. So with the impedance of dy, the angle of theta. So for example, if we have VAN as VP angle 0, VBN is VP angle negative 120, and VCN is VP angle 120. So IAA, AA, so IAA is just equivalent to VAN over dy, or we have magnitude IAA angle of negative theta, or this is equivalent to IL angle of negative theta. Now our ICC is equivalent, so this is a balanced load or a balanced system. So we have IL negative theta plus 120. So now we'll just get the values for the line voltages. So we have VAB, we have, so root of 3 times VP is just equivalent to VL angle plus 30. Then we have VBC plus VL angle negative 90, and VCA yes VL angle 150. So getting the power measured by wattmeter 1, so we have VAB times current IAA, cosine of, what is the angle of VAB? Just 30, and we have negative theta. So minus negative theta, we have positive theta. Or we can rearrange this to VAB IAA cosine of theta plus 30. So for wattmeter 2, we have the voltage VCB, then the current ICC, then cosine of, what is the angle of VBC? So VCB. So VBC equivalent to negative VCB. So VCB, yes, EL is angle of 90. We have VCB has the angle of 90, and then our ICC is the angle of negative theta plus 120. So minus negative theta plus 120, we have plus theta minus 120. We have VCB ICC cosine of theta minus 30. So since this is a balanced system, VAB and VCB have the same magnitude. We can rewrite this as VL. Same goes with the line currents. So IL cosine of theta plus 30, and then the VL IL cosine of theta minus 30. We saw earlier that the sum of the two wattmeters is just equivalent to the total power. We can say that meter 1 plus meter 2 is equivalent to what is the total power for a uh, balanced three-phase system. If you remember, total power for balanced three-phase systems is just equivalent to square root of 3 VL IL cosine of theta. Now, if we get the difference of wattmeter 1 minus wattmeter 2, we get this equation negative PL IL sine of theta. Or meter 2 minus meter 1 equivalent to PL IL sine of theta. So the derivation of this equation and this equation using the trigonoid entity, sine of A plus minus B is equivalent to cosine A cosine B minus plus sine A sine B. So if we take a look at this equation right here, now take note that a total Q for balanced system is square root of 3 VL IL sine of theta. So using equation right here, we can say that QT, the Q total, equivalent to square root of 3 times of meter 2 minus meter 1. Now following the power triangle, we can get the relationship between the Q total and the P total using the tangent. So tangent of theta equivalent to QT per T. So let's just draw our power triangle. So let's assume a inductive load. We have theta, QT, and PT. We have tangent. Theta equals to QT over PT is equivalent to square root of 3 meter 1, wattmeter 2 minus wattmeter 1 over meter 2 plus meter 1. Now using this relationship, we can get the value of our theta. If we have the value of theta, we can now get the TF equivalent to cosine of theta.